Hi everyone. My name is Abhigya Lamichhane. This is my final presentation for predicting diabetes prepared for HAP 671 class at Health Informatics program at George Mason University. Why is it important to screen for diabetes? So according to National Diabetes Statistics, total of 37.3 million people have diabetes, which contributes to 11.3% of the US population. Among them, 28.7 million people are diagnosed with diabetes, whereas 8.5 million people has diabetes but are not diagnosed, which contributes 23% of adults that are not diagnosed. Moving on to the next slide. Moving on to the next slide, we have our data source, the total number of patients on the record and the total number of unique patients were calculated from DBO final table. This data was simulated from major healthcare institution in United States, and we can see the size of data that are used for predicting diabetes. Moving on to the next slide. Diabetes was defined using the CSS code, which was converted to ICD-9 codes, and which was cleaned and then used for predicting diabetes. On the next slide, we have predictors. These are the set of diagnoses that are used to predict the presence of diabetes or the patient who have risk of diabetes. The total number of patients or total number of ICD-9 codes were 5,270. And some of the examples of important predictors were unspecified essential hypertension, other secondary pulmonary hypertension, chronic obstructive pulmonary diseases, unspecified atrial fibrillation, and congestive heart failure, unspecified. Moving on to the next slide, we have obvious predictions. These are the obvious diagnoses that always occur with diagnosis or have the word diabetes in their name. Some of the examples are diabetes mellitus, pulmonary hypertension, unspecified essential hypertension, diabetes with peripheral circulatory disorders, and diabetes with unspecified complications. Moving on to the next slide, we have rare diseases. These are the ICD-9 codes of 10 rare diseases that are predictive. Some examples are esophageal reflux, neurotic disorders, and renal failure. Here we got the rare diseases from the ICD-9 codes that occur more than 29 times. Moving on to the next slide, we have most predictive but not obvious diagnosis. For this one, the given examples, the given ICD-9 codes are the examples of 10 most predictive diagnoses, but that are not obvious diagnoses for diabetes. On the next slide, we used naive-Bayes to aggregate data from individual diagnoses to predict the overall risk factors for diabetes, as well as calculated cutoff values and specificity and sensitivity. As you can see, we also calculated likelihood ratio based on the data provided for diagnosis of diabetes with or without complications. On the next slide, we have case with 5 different diagnoses. I used the ID 2176, and it had about 41 ID repetitions, and with the likelihood ratio calculated, it has very high prediction for diabetes. And the given example, this case has a high likelihood ratio, which resulted in high value of probability. As you can see, this is a high value of probability, and the patient has high probability of getting a diagnosis of diabetes. Moving on to the next slide, we set aside 20% of data for validation and 80% of training data set, which was later used to get the percentage of patients with undiagnosed diabetes. And these data were also used to calculate the calculations during naive Bayes. For the cross-validated accuracy, as I said before, we calculated sensitivity and specificity, and this was used to create a receiver operating curve, and we also calculated the area under the curve in this diagram. And lastly, we have summary. So the diabetes predicting model can be used for improving the overall population health. And it also aware patients of diabetes screening, and with more and more use of predictive model, it will improve the more screening of diabetes in the long run. I hope you guys enjoyed the presentation, and I was able to help you with some predictive analysis of diabetes. Thank you.